good, 94. I'm also really good at teaching, right? Stick with what I got. 94, recall, in case you didn't remember, hopefully at least the first one you remember, that water freezes at 0 degrees Celsius or 32 degrees Fahrenheit. So hopefully that's the one you remember. So we have 494. Oh. So 0 degrees Celsius and 32 degrees Fahrenheit. Okay. And then they tell you that it boils at 100 degrees Celsius or 212 degrees Fahrenheit. Which that one? Maybe you didn't remember the Fahrenheit temperature. I don't know. Our goal is to write an equation that models this information. When you write an equation, you need two things. To have an equation, you need the slope and the y-intercept when we're talking about linear equations. So if we have a linear equation, we need those two things. One of these might help you get either the slope or the y-intercept if you think of them as ordered pairs. So instead of thinking of it as just numerical like temperature values, treat this as an ordered pair. So at 0 degrees Celsius, if that is my x, the y then could be Fahrenheit. And for 100 degrees Celsius, all of my x values can be the Celsius, so the y could be the Fahrenheit temperature. Which one of those then would help us find either the slope or the y-intercept? How could you use them to find the slope and the y-intercept? Maybe I'll rephrase that. Chelsea?
You could do 212 minus 32 over 100 minus 0.
Yeah, so 212 minus 32, so y1 minus y2, 100 minus 0. And when you do that, Chelsea, that becomes 9/5. Yeah, that's what it reduces to. So it reduces to 9/5. So that's the slope, or 1.8 if you had 1.8. How do you get the y-intercept? Libby?
Well, so I did different letters because for Fahrenheit and Celsius. So I did F equals the slope, so that'd be 9/5.
Perfect.
C for Celsius.
Yep.
And then I did plus 32 because that would be the y-intercept.
Perfect. Right here is your y-intercept. Because 0 is x, y is 32 degrees. So if you had it as y equals 9/5 x plus 32, that's fine. But kind of translating it to use the Fahrenheit and the Celsius, because this is actually a formula that you can use to convert from one to the other. So Fahrenheit really is equal to 9/5 times Celsius plus 32 degrees. So if you were in like Mexico, where they measure their temperature in Celsius, or anywhere in the world besides the United States, and you were like, wow, what's 48 degrees Celsius? Instead of asking Siri, you can figure it out yourself. Be like, all right, well, 48 degrees, add 2 or 32 to it. That gives you like a rough value. Take 48 degrees, multiply it by 9/5 or approximately 2, and then add 32. You could like convert your temperature, or you just ask Siri, I guess. Good question. So treat those points like the values as ordered pairs. Is there another one you'd like to go over? Yeah, no, actually, good. Yeah, that one's the one with the point and the equation, right?
Yeah.
This is. So if we look at 75. So it gives you an ordered pair, and then it gives you an equation of like x plus y plus 2 equals 0. The ordered pair is negative 4, 1. And then y plus 2 equals 0. And then it says we're supposed to find, this is in the group of the problems where it says find a parallel line, find a perpendicular line. So we've got parallel, and and perpendicular. Oops. So Eris, really the equation we're working with is instead of y plus 2 equals 0 would be, y equals -2. All right, so because I just have y equals and an ordered pair, I'm not going to use slope-intercept form. I'm going to think about it as a graph, as a picture. So on my graph, we have a line at y equals -2. Okay, what kind of line is y equals -2? Horizontal. So you go down to -2. On the y-axis, you make a horizontal line. Okay, so now I got this horizontal line. We're supposed to come up with another line that's parallel to this, but also goes through the point -4, 1. Right here. So Kate, if you have a horizontal line, what's the only line that's going to be parallel with a horizontal line? Another horizontal line. And if it goes through the point -4, 1, it has to look like this. What's that equation, Kate?
Y equals 1.
Yeah, y equals 1. So my horizontal line that was given, y equals -2. Now I have a horizontal line going through the point -4, 1, because those would be parallel. Perpendicular means what? What's perpendicular mean? Nick, if I align two lines that are perpendicular, what's that mean? Say it again, Brandon.
They cross forming 490 degrees.
Okay, so they cross forming 490-degree angles. Nick, if I have horizontal lines, what kind of line would be perpendicular with it?
A vertical line.
A vertical line. So now our vertical line has to go through the point -4, 1. So here's that point -4, 1. That looks pretty perpendicular. Not too bad for a little sketch up here. And Nick, what would that equation be?
X equals -4.
Nice, x equals -4. So sometimes when you're just dealing with vertical and perpendicular, or vertical and horizontal lines, like making a little drawing, doesn't it make more sense? Like seeing the drawing, kind of looking at it, saying, all right, I got this point, now I can physically see the lines. What's going on with that? Really good question there. Good question. All right, so today we're going to talk about some fun stuff. Fun things called functions. We're going to evaluate functions. Hopefully we should get to find some domain and range of functions. But we'll also talk about something called the difference quotient, which is the new part. So we'll review functions, we'll review evaluating, and then we'll get to a little bit of new information. And that is section 1, 2 of your notes packet. You can sit anywhere in the back.
Why not? Would anyone like any tips?
So after
Oh, because I get.
Maddie, I'm actually going to ask you to go next door. I'm sorry. Only because I'm talking about functions right now, and the second question on your test deals with functions.
You're good.
So I would give you the answer.
What's
while
wrong with
sitting in
that?
the room. Well, you know.
I think we should just leave her.
Yeah, you think it's okay for her to
Yeah,
answer?
just
Over here.
Well, they like
There's
it.
your one question.
Not gonna hurt anything.
Why did you guys bring that? So accurate.
No one.
I remember
Look.
Yeah.
I'm good, that was. Good, please, anyone? Alex.
Good.
Brandon, what's a function? Function.
The example.
What's a definition of a function? It was on your chapter 2.1 to 2.4 quiz
Oh, so
from last year.
from last.
Yeah. from last year.
Is this what we kept getting wrong?
Yeah, that's what she's taking right now.
So is it where like one input can only have one output?
Yep, that's it.
Oh, that thing.
So we say it's a relation where each input must have exactly one output. Where each x can be paired with only one y. Input x, output y. So a function can be as basic as a set of points. And I'm going to give you two sets of points here just to kind of refresh what a function is. So if I had a set of points, okay, so there's one. And here's my second one. So a relation is as basic as a set of points, or a relation could be a really long and involved equation. Essentially anything is a relation, only certain things are functions. So between these two examples, which one of them is a function? Right?
The first one,
Why?
because, each x, is paired with one y. The same y can be paired with different x's, but, two x's can be paired with different y's.
Okay, so it's okay to have 5 negative 1, 6 negative 1. It's alright for the y's to be the same. But it's the x's that we're looking at. And in the second example up here, the x value of 4 is paired with negative 3 and 4 is paired with negative 7. So the x value of 4 has two outputs, which isn't allowed to happen. That's why this one is not a function and the other one is a function. Because each x only has one y. Alright, so that would be the basic when you're just looking at a set of points. Function versus not a function. Underneath, we can try and also look at equations and decide if they're functions. And we can look at graphs and decide if they're functions. Right now we're just going to work with the equation part. Is y a function of x in the following equations? First one says x is equal to y squared. What do you think you do first with that? Like x equals y squared. Ready?
The square, or just convert the
Yeah.
squared, so you do square root.
Right. I mean, usually when we have an equation, it's in y equals 4. And that's what y is a function of x means. Like, you should have y by itself. So she said, take the square root. Libby, when you take the square root to solve for something, what goes with the square root?
Plus or
A
minus.
plus or minus. Because you are applying it to get rid of something that's squared. And anytime you do that, you need a plus or minus. Because a squared term has two sides to it. There's two parts there. So now we have y equals plus or minus the square root of x. So it's y by itself. If you're still not sure if it's a function, test a couple of numbers. I'm just going to make a little t-chart here. I don't know, like I have y equals plus or minus the square root of x. What does that really mean? How do we know if it's still a function or if it isn't a function? So pick a couple numbers to plug in. Brandon, what would a couple good numbers be to plug in for x?
Do they have to make sense?
That would be great, yes, because I did say good numbers.
59.
Okay, no. Virginia,
4.
thank you. How about one more, Virginia?
16.
Okay. Virginia, the square root of 4 is, but when you're solving for y equals plus or minus the square root of x, it's plus or minus 2, because we're going to plug it in for this x. We're plugging a 16 in for x as well, so we have plus or minus the square root of 16, so the answer is plus or minus 4. Brandon?
That's not a function.
Because 4 is paired with 2, and 4 is paired with negative 2. 16 is paired with 4, and 16 is paired with negative 4. This is not a function. So the one y value, or one x value, gives us two separate y values. So this one here is not a function. So when you're looking at it, like actually plugging in a couple of numbers, you get out the y values, you're getting two different y's out of the problem. Looking at letter B, thinking about it the same way. So just putting in a couple numbers so you have a visual, so you can get a gauge as to what we're looking at, what we're thinking about. We have y equals the square root of x plus 5, so y is already by itself. What would two good numbers be that we could plug in, Chelsea?
-1
-1.
and then 11.
Okay, 11. Those seem good. So if you plug in -1 in, Chelsea, we have the square root of -1 plus 5.
It's just 2.
It's just 2. Why isn't it plus or minus?
Because you're not taking the square root.
Exactly. It's already in the problem. You didn't take the square root of it. It was given to you. So it's just 2. When you plug in the 11, 11 plus 5 is 16. The square root of 16 is just 4 because it's just the square root. There's not a plus or minus sitting in front of it. Anybody remember what the graph of a square root looks like? Virginia? Yeah, it's just that one part. It's just a positive hook part to it, which is why you have a positive answer. This one is a function because you're only getting out one answer. So square roots are tricky. And remembering one plus or minus should be in the problem versus when it isn't in the problem. If it's given to you and you didn't solve for it, then it's just the positive answer. If you were solving the problem and you apply the square root, that's when it's a plus or minus because you're trying to get rid of an x squared. Questions? The other term down here is function notation. So remember this from last year. We read it as f of x, that's how we said it. And it looked like f with parentheses around the x. The x inside is your independent variable. Or it could be a g of x or an h of x or any letter. It's going to look like a dependent outside and an independent inside. Questions? Alright, so we're going to evaluate 3 separate problems dealing with one equation or formula. And that formula is V with parentheses R. What do you think V stands for? Grace. And the R is radius. Do you know what the volume formula represents up here, Grace? 4/3 pi r cubed. Yeah, nice job. This is the volume of a sphere, 4/3 pi r cubed. So we're going to find what the volume would be if x is 3. You don't need your calculator, I promise. We're going to do some mental math. No calculator necessary. So we have 4/3 pi, and then when you're evaluating, whatever's in parentheses is what we use for x or y or r, but the 3 represents our variable. So r is now 3. All right, Ka, how's your mental math today? Not good. What's 3 cubed, Ka? Yeah, that's not too bad. So now we have 27. Pretend that 27 is over 1 and just look at the 2 fractions, ignore the pi. How could you reduce those 2 fractions so that we can get them to multiply together? What's a quick way to multiply them together? Without actually like multiplying, not, or 4 times 27. What can I do to reduce them? Chelsea? Cross, cancel. I think that's what you meant. So, yeah, sure. So Chelsea, if I look at the 3 and the 27, we can take out a 3 and make this a 9. So that's cross canceling, reducing the fraction diagonally, and then multiply. So now we have 4 times 9, which is 36. Over 1, but we don't need to put it over 1. And then you got this little pi guy here, and I'm just going to put that pi after the 36. I told you not to get out the calculator because you don't need to make the pi 3.14 and get an actual nice answer. When we hit trig, 95% of our answers are going to have pi in it. We'll be working with a lot of pi, especially around Thanksgiving time when you really start eating pie. We'll be talking about pi and pi.
Can you bring pi into class?
Maybe. That might be one time, Brandon, that I might say okay.
It's the last period of the day.
Yeah.
And you have to deal with me.
All right, so the next one says V with 2R in parentheses. So if we plugged a 3 in for R and we evaluated it, now we're going to plug a 2R in place of R. So we have 4/3 pi, and instead of R cubed, whatever is in the parentheses replaces R. So in parentheses, instead of R is now 2R, and it's cubed. And we evaluate just like we did on the other one. So 4/3 pi. Michael, do you know what you do with 2R cubed?
It'd be 2R to the 4th.
Little
Or
less.
it'd be like,
Cube each of them.
oh, it would be 8R to the
You're so close.
4th. Or 3rd.
Third, yes. So 8R and then cubed. Because you're just taking that cubed. You're allowed to apply it to both because they're being multiplied. There's not a plus sign. It's not a quantity. It's just a single term. So you apply it to the number in the variable. Can we cross cancel those? No. So you're going to multiply the top. 8 times 4 is 32. The bottom, 3 times 1 is just 3. And then we still have a pi. And we have there it is, R cubed. And you can just stick them next to the fraction. So we have the number, and then you got the pi, which is actually a number, and then you have the variable R cubed. Questions? So evaluating just means plug something in, get an answer out. Sometimes it's not going to be a number, it might have a variable in it, depending what's in the parentheses that you replaced for the variable. The last one here, we've got 4/3 pi, and now we're using 3/2 for the radius. It's cubed. Alice, do you remember how we cube a fraction?
Well, no.
Oh no.
So, would it be the top
Mm-hmm.
cube and then the bottom cube?
Mm-hmm. Yep. So when you cube a fraction, top cubed, bottom cubed. And then reduce if possible. Cross cancel. So Alice, do these reduce? Di-
3, 27. So,
So that's 9. The 4 and the 8.
yeah, and so it would be 9 over 2.
Perfect. 9 over 2. And then the pi can go right next to it. However you make your pi is up to you. I put a little curly hat on it, but you can just make pi like that. It's totally up to you. Whatever you want to do with your pi right now. Questions? Questions of evaluating. Alright, so we're going to take this evaluating and we're going to apply it to a function that's a little bigger. And the evaluating part also becomes a little bigger. You look over here, we have a couple of pieces in this problem. So our equation is x squared minus 4x plus 7. That's the function. It says to find, and then when you look at this, you're going to read this as f of x plus h instead of f of x, minus f of x, and then divided by h. This is a special concept that we will use repeatedly throughout the year except in trig. But we're going to use it in the first couple chapters, and then at the end of the year, we'll do that like full circle moment. Oprah Winfrey, when she was on, she talked about like she had them all the time, full circle moments. You guys remember Oprah?
You get a card. You get a card.
Yeah, see, he remembers Oprah. Of course he does. So this is called the difference quotient. She did give a lot of prizes out.
She also really likes bread.
Can't go wrong there. So, difference quotient is a concept that we will eventually apply to calculus, and the first part of calculus is built off of this. Right now, I can't really tell you how that is represented and what it means because we need to do a lot of the pre-calc first. But our goal is to kind of just work on the evaluating and the algebra of it. So some of it's going to seem weird and it's not going to make a lot of sense, and that's okay. But the process is what we're going to work on right now. So a difference quotient is called a difference quotient because you're taking the difference of two quantities and you're dividing by something else. Dividing means quotient. So that's how it kind of got its name. We're gonna split this up and look at it as separate pieces. So I need you to pretend that we're really evaluating. So the first step, we're gonna just try and evaluate, I'm gonna split it apart. This f of x plus h. So this is just like the 3 problems above. It said to evaluate, so now we're evaluating. But we're using this equation right here, x cubed minus 4x plus 7. Whatever's in parentheses represents x. That's what you replace x with. That's what the f means. The f means go to the function, replace x with what's in parentheses. So if you do that, instead of writing x squared, what would you write? Brandon?
X squared minus 4x plus 7.
What's replacing the x squared? What's that going to change to? Virginia?
Would be x plus h squared minus 4x plus h plus 7.
That's perfect. So this still says x squared minus 4x plus 7, but x changed because we're evaluating it instead of using a 3. Like we could plug in a 3 for x, but now we're plugging in this quantity x plus h. Questions with that stuff? Right, so you need to simplify. So if you have x plus h and it's squared, that really means they're double, there are 2 of them. Does anybody know if you multiply x plus h times x plus h, what that makes? Alice?
Well, the x squared plus 2xh.
Yep.
Plus h squared.
Perfect. So just looking here, x squared, and then you have xh and another xh if we write them with the x first. So that's why there's 2 of them, and then the h and the h make h squared. You know, that's different. So then we have a minus sign. Taking the negative 4 into the parentheses makes negative 4x, negative 4h, and then plus 7. Even this looks different because it's pretty big. You have 2 variables. Do any of them combine together? But we've evaluated. Like that's what you've really done right there. Like we did above for the 3 problems, that has been evaluated. So now we're going to try and look at the second piece of the difference part. So I'm going to look at that minus f of x, or another way of saying minus is negative. So we have negative f of x. Brandon, what equation represents f of x?
So, x plus h squared minus 4x plus h plus 7. But we're going to have to change it to negative.
We're going to have to change it to negatives. But we're just using this original equation up here. So the x squared minus 4x plus 7. Brandon said we're going to have to change that to be negative. Because it says make f of x negative. That's what this means. Take your f of x, make it negative. So Brandon, if we make it negative, it becomes
Negative x squared plus 4x minus 7.
right. Now, on the bottom is just a lonely h by itself. It doesn't have an f with it. So if there's not an f with it, you don't do anything with it with regard to the function. That's what the f means. So when that f is in front, that means go to function f and do something with function f. There's just an h in the denominator, so we're not going to do anything with the h. So what we're going to do is we're going to try and take these 2 pieces, this piece here and the big piece. And we're now going back into the original fraction. We're going to have this huge expression. So my 2 pieces that I separated, we're going to bring back together. And you won't have to separate them every time, but it makes it easier the first couple times just to see the parts and how they kind of form together. So the first part, we had x squared plus 2xh plus h squared minus 4x minus 4h plus 7. That was the first part. The second part, Brandon just told us, was negative x squared plus 4x and then minus 7. So we have 1 piece, 2 pieces, and then don't forget that little h now to make it that quotient part. So the top is the difference, the bottom, the h makes it a quotient. So Sabrina, what happens here?
You just like take out all the things that you're subtracting, so it would become 2xh plus h squared minus 4h over h.
You said 2x squared minus h squared minus 4h. Okay, so let's look at this. If you're looking for like terms, notice the x squared is positive and negative. The 4x, we have a negative and positive 4x. We have a positive and negative 7. That happens every single time. You're going to have a whole huge expression, and then you like cut it in half because you're canceling all these parts out of the problem. Sabrina, do you notice anything with the expression that you have left?
And you can take out an h out of each of them.
Whatever you have left should have the part in the denominator in it. So the terms that are remaining should have that denominator in common. So she said take out the h. And then our h's cancel. Every single one of these, the denominator will cancel if you've done it correctly. So that's kind of like a little note to yourself. If you've simplified correctly, the denominator should be pulled out and you can cancel that quantity out. So our answer, and this looks weird, and it doesn't really mean anything right now except that it's an algebraic expression. We have 2x plus h minus 4. Questions? So the last thing here, we're going to really start kind of looking at denominators and thinking about if you're evaluating, there's something that the denominator cannot be. Because evaluating means we can plug numbers into the problem. So if I look at the problem, what can't h be if I plugged numbers into it from the very beginning? A 0. So that is something that we'll really start kind of defining this year. Anytime you have a fraction, we're going to say, all right, x can't be this number because it started in the bottom of the fraction. And that becomes part of our answer. Questions? Brandon, you're not, no question? Just-
No question.
Okay. So we're going to go to the next page. I know that was a huge problem. Make sure on Sunday when you go do your homework or Monday morning that you reference that problem because there's 2 in the homework that are going to be similar to that
Good
problem.
afternoon. Any student in grades 10 through 12 interested in information on the North Hills Academies, please sign up in the main office. The 6 academies are Arts and Communication, Business and Finance, Engineering, Law and Government, Medicine, and World Affairs. Just stop down in the main office and sign up for information. Thank you.
So the other thing, I know I skipped a couple pieces and we'll come back to them on Monday. But the other thing I just wanted to kind of review with you was domain, not range, just domain right now. Does anybody remember if domain is the x or the y term? Chelsea?
It's the x.
Yeah, it's the x term. So the domain is x. So there's 2 different ways that domain is given. It's either explicitly, I mean it literally is given to you. So if we have the equation y equals 2x squared plus 3, and they say x is greater than or equal to 0, that's the domain, because domain is x. So in this problem, all the x's must be greater than or equal to 0. So that's called explicitly. If I'm asking you to find the domain and I give it to you, well, I'm not really telling you to do too much. Ours is usually going to be implied, meaning we have to find the domain or determine the domain from the equation. Or from the function. So it's in there, we can calculate it, but we have to remember what you have to do to calculate it. So there's 2 problems underneath here, just a little quick review of domain. We'll do more examples on Monday. 2 different parts here, one's a fraction, one's a square root. So if you have a fraction, and the x is on the bottom, because that's what we're focusing on, domain is x. What can't you have in a denominator? Eris? 0. So whenever you have a fraction, you're focusing on the denominator. That fraction cannot be 0. So I'm ignoring the 1 on the top. If you solve the little equation in the bottom, so x squared is not allowed to be 9, and take the square root, Eris, what can't x be? -3 and +3. Because the square root of 9 is 3 and -3. 3 squared is 9, 9 minus 9 is 0. It can't be those values. When we write domain, I'm just making a little picture here so it makes a little more sense. We solve this problem. It's not allowed to be -3. It's not allowed to be +3. But it's allowed to be any other number. How do you write that in interval notation? How do you show that, Alice?
Well, so it'd be -3 to -3, and then 3 to infinity with the parentheses around the
Okay, so she has -infinity to -3. That gives me this part down here. She also gave me 3 to infinity, and that gives me this part up here. Parentheses means it can't be that number. But Alice?
It can also be -3 to 3.
It can also be -3 to 3 because it can be in between those two numbers. So that's how you write interval notation. If you're saying it's not allowed to be these two numbers, but it can be anything else, the parentheses around the 3, that's what that means. It's allowed to be any other number but those 3s. Questions? All right, one last problem in the 2 minutes that I have here. I'll go through this quickly. If you have a square root has to be greater than or equal to what? 0, because it cannot be negative. So if you solve that for little equation, that x minus 4, x has to be greater than or equal to 4. So essentially, you're focusing on the equation. A denominator can't be 0. A radical has to be greater than or equal to 0, or greater than or equal to 4. So in this case, here's my 4, greater than or equal to, would say that it's allowed to start at 4, and it can be 4. 4 minus 4 is 0. You can take the square root of 0, and it can go to infinity. I know we went over like a lot of stuff in one period. Do the best you can with your homework. You might have to refer to your notes a little bit. I skipped piecewise functions. I'll go over piecewise functions again on Monday, but give yourself a little refresher. Try those problems even though I skipped over them.
I can't remember if I enjoyed or
I
hated.
think I had no idea this one, so if you don't mind like going over it like on Tuesday or Monday or whenever. So. Like I try to do work, but I don't know if it's probably not.
Okay, sounds good.
Alright, thanks.